Hello everyone, welcome to Easy Physics. In this video we are going to learn spherical mirrors. We call them spherical mirrors. Why? Because they are part of a sphere. Here is a mirror. It is part of this sphere, and we have another mirror here. It's also a part of this sphere. In the case of concave mirror, light reflects from this inner surface. This reflective surface, is curved inwards. Similarly, light reflecting from this convex mirror, from the reflective surface of the mirror, and this reflective surface is curved outwards. And this straight axis is called principal axis. It is passing through the center of the sphere and then through the middle of the mirror. And we call this distance as a radius of the curvature, and it is called r. The half of the radius of the curvature is called focal point, and this distance is equal to this distance. So focal point will be equal to a radius divided by 2. One last point. The middle of the mirror is called the pole, and we denote it with letter P. So after definition of concave and convex mirrors, let's move to the ray diagrams in concave and convex mirrors. The first rule for the reflection of the light rays from the mirrors is a straight line parallel to the principal axis. This one and this one are parallel to each other. It reflects and passes through the focal point. Similarly, a straight line parallel to the principal axis of the convex mirror will reflect like this. And what is important here is its extension of the reflected ray is passing through the focal point. The next rule is a parallel ray, a ray passing through the focal point coming to the mirror surface will reflect parallel to the principal axis. And in the case of the convex mirror, a parallel ray will reflect like this. A light ray coming to the mirror, to the convex mirror, will reflect parallel to the principal axis, but the incoming light ray is coming toward the focal point of the mirror. The next rule is a light ray coming to the pole of the mirror will reflect like this. And what is important here is the principal axis divides this angle into two parts, and this part becomes equal to each other. It is similar in the case of the convex mirror. Again, a light ray coming to the pole will reflect like this, again making the equal angles. The next rule is a light ray passing through the center and it comes to the mirror surface, it reflects over itself if it is coming through the center. It is similar in the convex mirror. When the light ray is coming toward the center of the mirror, it will reflect over itself. So these are some special light rays. What is the general rule for the reflection of the light rays from the mirrors. Assume we have a principal axis. And let me draw a concave mirror. Any light ray, assume, for example, this one, how it will reflect from the mirror. In order to reflect this one from the mirror, first we need to draw the normal from this point. And normal is a straight line passing from this point and also passing from the center of the curvature. Now assume that here is the focal point F, and here is the center. Now this light ray is going to reflect from the mirror, making equal angles with the normal. Let me draw the normal. So this is the normal, and the incident light ray will reflect, making an equal angle with this one. This is the angle of incidence and this is the angle of reflection. This is the general rule for the reflection of light in concave mirrors, also in plane mirrors. So let's try it here. For example, as you see, the principal axis here also is the normal, and this angle is equal to that angle. What about this one? Here is the center of the mirror, approximately this point is the center. Let's draw the normal at this point. Here is the normal. As you see, it divides the angle into two parts, this one and that one. You can also draw this case for other light rays reflecting from the mirrors. Let's move to solving some problems. Okay, we have two mirrors. The focal point of one of them is F and the other one is 2F. A light ray, after reflecting from both mirrors, reflects back over itself. This light ray reflects from this mirror, then reflects back over itself and then move like this. Okay, so here is the light ray coming to this mirror on the right. It reflects and then moves to this mirror on the left, and it reflects back and then moves like this. So what is the distance between the mirrors? As you see, the initial light ray parallel to the principal axis is going to move through the focal point. Remember our first rule: parallel light rays reflect from the focal point. And the second, this light ray is going toward the mirror on the left, and it reflects back over itself. Now let's go to our rule: any light ray passing through the center reflect back over itself. So it means that this point is the center of the mirror on the left. Its focal point is F. The total distance will be 2F. The total distance will be 2F. So what is the distance between the two mirrors? As I said, the first initial light ray parallel to the principal axis is going to reflects from the focal point of the mirror on the right, and its focal length is 2f, and this point is the focal point of the mirror on the right. Is also the center of the mirror on the left. So what is the distance, total distance between the two mirrors is 2f this distance and 2f this distance. Totally it makes 4f. Okay, let's move to the next one. A light ray is striking the mirror surface and then reflects like this. As you see, this line is dividing the angle into two parts. It means this is a normal, and in the case of the spheres, this normal is the normal is passing through the center. It means this point is the center. So remember, focal point was equal to center over 2, or radius divided by 2. So it means that this point is the focal point. And in the question it asks the focal point. What is the focal point of the mirror? Point L is the focal point. The next question. A light ray parallel to the principal axis. As you see, this one and that one, they are parallel to each other. So this parallel ray is striking this mirror on the left and then reflect toward the mirror on the right, and then it reflects back like this. What is the distance between the mirrors in terms of f1 and f2? The focal length of this one is f1, the depth of that one is f2. Sorry, this is f1, this is f2. So this parallel light ray is reflecting such that it's going to pass through the focal point. It means this is the f2. This is point f2. And then, as you see, this light ray strikes this convex mirror and then it reflects back. Remember our rules. Light ray comes to the convex mirror and reflects back. It means it is coming toward the center. So it means this light ray is coming toward the center. This point is also the center of the convex mirror. It means this is 2f1. It is 2f1. So we are asked to find the distance between the two mirrors. Here is the distance between two mirrors, and let's call it x, will be equal to the total distance from this mirror and to this point is f2 minus this distance. If I subtract this distance, I will get the distance between the two mirrors. That's why 2f1. So in terms of f1 and f2, the distance between the two mirrors is f2 minus 2f1. Okay, that's enough for the special ray diagrams. In the next video we are going to continue with the images formed by concave mirrors.